you're getting a feeling that you're seeing too much of me, this is my last session in this track, I promise. Right? What we're going to do is have a joint track on this between us, that is AWS, and Trend Micro. So what I'm going to talk about is just kickstart this and talk about integrities of our security offerings and how we actually behind the scenes run a lot of checks to actually secure our infrastructure. And we'll have Shraddha, Tickoo from Trend Micro come up on stage after that and talk about their service, some of their services which actually complement us and form a layer on top of our infrastructure. Right? We already spoke about this in my session, right? Security is a shared responsibility on the cloud, right? You actually take care of your operating system and your applications on top of it. We actually take care of everything below it, right? What that means is right at the bottom, you have the earth, right? And you have mud and soil on top of it, and you have dirt on top of it, and then you have stones on top of it. And then you finally have the floor of the data center on top of it with all the tiles on which you can walk, right? Then you have the 4 walls and the ceilings and the big doors and bolts and locks of the data center, right? And then finally, you have all the racks and the servers and the networking infrastructure inside those data centers, right? All that is our responsibility, be it operational or security-wise, right? What we do is, it will be no good about me standing here and talking about some of our security processes and how secure it is, because we understand you might want to hear from third parties as well, right? And what we've done is exactly that. We've actually worked with independent third-party auditor firms, right, and actually undergone security accreditations on a variety of our services that you hear, that is our infrastructure, right? SAS 70 Type 2 audit was in place for a long time. It's actually been replaced by something called a SOC 1. We are actually certified for that. There are other certifications like ISO 27001, PCI compliance, and FISMA, right? What a lot of customers have done is, and this has helped them, is when they build applications on top of our infrastructure, knowing that our infrastructure is actually certified under certain security accreditations, makes it easier for them to make their application in compliance with certain security accreditations as well, right? For example, if you have a website and you want to do credit card transactions and store credit card data, right? Knowing that our infrastructure is payment card industry DSS level certified helps, because that makes it easier for your application to be certified, right? If you've actually heard of a small company which started off as an online bookstore and grown now called Amazon.com, they actually run on AWS, right? And they store thousands and millions of credit card transactions and credit card data on them, completely on an AWS platform, right? And because they've actually built a PCI compliance stack on top of us. How do we do that? There are various aspects of it, right? And it could take days for me to explain. We do it in general physical data center security, networking, storage, EC2 infrastructure, security groups, etc., etc. Let's kind of look at a few of them, right? At the data centers, we stringently control right from the process of what kind of people we hire in the data center to right until what kind of access we give on their badges, right? If there is a data center employee who requires access to the data center temporarily to actually do maintenance activity on a certain rack of servers, he will only have access to do that for a certain amount of time, right? And after that, the access is revoked, right? I, being an AWS employee, I've never known the address of any of our data centers across the 8 regions, right? Anyone here who wants to kind of visit the AWS data center? Interested? Yeah, some of you? We don't allow tourists, sorry, bad news. The gentleman who actually runs our security, he's the head of security called Steven Schmidt, right? He does not have access to any of our regions simply because he doesn't need to, right? And even for the employees who already have access, we actually strictly control, log, and audit all the logs of access and actually review them on a constant basis, on a regular basis, right? Most of you might know this simply because if you have an AWS account, there's a good chance that you're using EC2. Some of you might know that EC2, our implementation of EC2, is a very highly customized version of the Zen hypervisor kernel, right? What we do is we work with the Zen community closely and actually are aware of the latest updates and greatest of updates, right? What we've done is a couple of things. The EC2 guest operating system, that is a virtualized operating system, is actually made at a privilege level which is much more lower than the hypervisor host OS, right? So if you understand the concept of rings, ring 0 to ring 3, the hypervisor OS is at ring 0, the guest OS is at ring 1, and the applications are at ring 3. So there's a clear demarcation of security levels between the hypervisor OS and the operating system, right? We've also built a specific firewall between the hypervisor OS and the physical interface of the hypervisor and the virtual interface of the EC2 instance. All packets, when they're going outside an EC2 instance, even if it's to pinging to itself, has to go out and come back. And that's the clear demarcation there. So that's to ensure that all your noisy neighbors or your EC2 instances that are sitting on the same hypervisor, which could belong to other customers or your competitors, right, have no more access to your EC2 instance than any other host on the internet, right? It's no different there. It's almost like being on 2 different hosts. You've heard during the trivia round in the morning when Joe was giving you prizes as to how many objects we have on S3, which is a simple storage service, which is 1 trillion plus as of June 2012, right? And we obviously need a few disks to store these 1 trillion objects, right? So we have lots and lots of disks. When you from the console delete a particular disk subsystem, could be EC2, could be EBS, could be S3 buckets, right? Irrespective of if you have any data on it or if it's encrypted or not, the disk will actually go through a specific list of checklist of processes to actually erase and degauss the entire disk, no matter what, right? It has to go. Ultimately, over a few years, once the disk ends its end of life of its hardware, we actually completely destroy it, right? Which I find fascinating. I always wanted to see this, right? Just imagine a crate of disks actually going into a shredder, right? Should be fascinating. No disks actually make it out of a data center, not intact anyway, right? What remains there is actually shredded off completely ultimately when it reaches end of life. Amazon does a host of standard as well as proprietary DDoS mitigation techniques, right, starting from the perimeter level, from the periphery and going inside, right? All our API endpoints to which you make the calls, made from the API or from the command line of the console, have SSL endpoints. We strongly suggest and recommend that when you're coordinating with our resources, when you're communicating to us, that you actually have all your communication encrypted with the SSL for obvious reasons, right? For various reasons as well, we do not allow any kind of multicast, broadcast, anycast, promiscuous mode, etc., on a network, right? We understand that by disabling multicast, this limits the certain number of applications that you can't move onto the cloud. There could be some monitoring applications, could be Microsoft Windows cluster, which requires multicast, but we are willing to make that trade-off for the sake of security, right? Obviously. Now, this is all that goes behind the scenes, right? This is what you don't see, right? All this is what I've explained is something that we do on your behalf, right? So what's in for you? Do you have any access to services to get better access control to certain Amazon services? Yes, we do, right? How many of you here are using identity and access management? Okay, that is sad. If you have an AWS account, you need to use IAM, right? That's compulsory, I'm not joking. First of all, it doesn't cost you to use anything, cost you to use IAM, right? And secondly, it gives you much more granular fine-grained control, right? Why wouldn't you want to use it? For example, if you have the main AWS account, right, you actually create sub-accounts for different users in your organization and submit roles and privileges to each of the users and give them the IAM privileges, rather than using the master account to actually rotate across users, right? If an employee leaves or is fired, you just turn off his IAM account, that's it, right? We also recommend strongly to use multi-factor authentication, get a VPN token, so that when you're authorizing on the Amazon platform, it's actually a combination of something that you have and something that you know, rather than just using a password, right? Security groups, there's a good chance everyone knows this, because if you have an EC2 instance and you want access to that, you will obviously have to use security groups. What I see here, a lot of customers getting wrong is use just 1 or 2 security groups for all your different types of EC2 instances, right? Which is not a good practice. Try and categorize your instance types into different categories as per their use case, right? So if you have a classic 3-tier architecture, web instances, app instances, database, right? Try and use security groups across the web instances which are different from app and database, because they will have different port requirements to be open, right? And when you're doing that in this diagram, in the security group of the app tier, you might want to open access to only your web tier, right? Same for your database tier, only open it to app tier instead of opening to everywhere, right? Also, when you're opening up access control, SSH or RDP to your Linux and Windows instances respectively, right? Do not open it to the whole world. This is a common mistake a lot of customers make, just because it's convenient, right? Only open it to the IP address or the range of IP address that's reminiscent of your organization. Finally, a virtual private cloud or VPC. How many of you are using VPC here? Anyone at all? Okay, a few of you. All right. So this is again a use case that we are seeing a lot often. It's not that resources running outside VPC are any less secure, right? People are running EC2 instances and they have all the security accreditations that we have, that I just saw you. But running in the VPC gives you that additional flexibility, right? For example, in this diagram, you could actually have only a private subnet, right? If you're hosting an internal CRM application on the cloud, for example, run an IPsec VPN tunnel from your data center, and that never sees the internet, right? So your application never gets exposed to the internet. You could do that as well. You don't have to expose all your applications to the internet. We also give you privilege for having access control list and outbound security rules in the security group, which is not there outside the VPC. So we're seeing an increasing use case on that. With that, I've come to the end of my presentation because I would like Shraddha to actually carry on. If you found this useful, what we have is some of the content that I discussed. We have an incredible level of details in a security white paper in the form of a PDF that we have publicly available at aws.amazon.com/security. you can actually go through all the processes that we have across our data centers to EC2 instances, and et cetera, et cetera. We also have a brief on some of our security accreditations and what are the services and how those services get affected by each of the security accreditations. You might want to go that. With that, I'll introduce Shraddha Tickoo from Trend Micro. She is one of the leads for their professional services organization and also a subject matter expert on the cloud secure service. Over to you.
Thanks, Santanu. Good afternoon, everyone. So, continuing with what Shantanu said a while back, is that when you talk about addressing security in the cloud, it is actually a joint responsibility of cloud service provider and you as a customer, right? Cloud service provider provides you with a trusted and certified environment, like you saw what all certification AWS, for example, has gone through to provide you a certified environment. But at the end of the day, it's your app which is going on the cloud. You are responsible to make sure that your application is not vulnerable to attacks, your application is patched, it has all the necessary controls in place, it is self-defending, and your data which is out there is protected from any rogue servers out there. Okay, so Trend Micro conducted a survey wherein we asked customers how they're securing your data, how they're securing their data in the cloud, right? Now, we got a very interesting result that we found that 85% of the people were actually encrypting their data in the cloud, and as equal amount of people were actually maintaining one-to-one copy of the data in the cloud, data which is there in the cloud, which is obviously not a best practice to do. When we talk about encryption, we would want you to put an additional layer of sophistication to an encryption when you are putting encryption on the workloads in the cloud. You may want your encryption to be backed up with a policy-based key management, which will give you control on when and where your data is being accessed. You would want that the server which is requesting access to your data should be validated so that you know that the server which is requesting this data is actually my server. And you would want to have the ownership of the key, the decryption key. You're encrypting your workloads in the cloud, so decryption key is the master key. And you as a customer, you as a data owner would want to have the ownership of the key. So these three things are required. Now, let's see in detail what all other things are required when you talk about encryption solution, in a full-fledged encryption solution, and when you move it to the cloud, right? It should start with an industry-based encryption. So, for example, in AES encryption, 128-bit, 192-bit, 256-bit, what encryption will do, it will render your data unreadable to outsiders. In an event when the drives are recycled, in an event if there is some residual data which is left behind, it will be again unreadable, right? Again, encryption solution should be policy-based key management. It should be backed by strong policy-based key management. What I mean by that is that the decryption keys should not be released to any VM who is requesting access to the key, right? It should only be given to a trusted server, which is your server. And even if it's your server, it should actually meet certain predefined criteria which are set by you as a customer, and then only a decryption key should be released, which, like I said, will give you control of when and where your data is being accessed, and it'll of course give an additional layer of security on top of encryption. The third thing, along with all these, there comes a desire to run audits, auditable reports, right? So, are you able to run certain reports which suggest when and where your data was accessed in the cloud? Or are you able to run reports which show you which VM requested access to your data, what time the decryption key was released, what time it was requested, etc., etc. So, again, a total encryption solution should provide compliance support. It should be able to run these auditable reports. And of course, last but not the least, the custody of the key. You as a business owner should have the custody of the key. And again, it's the best practice that the key resides with you and not with the cloud service provider to provide proper separation of duty. Okay? So that's what Trend Micro Secure Cloud offers to you. It's an encryption and key management solution for private, public, and hybrid clouds. So what is it? So we'll just go into the basics of what is Trend Micro Secure Cloud. What does it do? It encrypts your data which is there in the public cloud or private cloud environments. The encryption agent is FIPS level 2 compliant. It is a military grade certification that the secure cloud agent has undergone. So that's the basic thing that it does. It encrypts your workloads in the cloud. your volume in the cloud. The second important thing it does is it manages your encryption key. Again, managing an encryption key is typically a very tedious and time-consuming process. So yes, it does it for you. It manages your decryption keys. And even there is also a model where you can actually offload that, your key management server to a trusted partner, maybe another cloud service provider or to Trend Micro, right? So there are options. Or you as a customer can still have access to key management server. Another important point which it does is it authenticates. Now, I'll go into the detail. What do I mean by authenticating? Now, if you have a public cloud environment, you have your VM which is requesting access to data. Like I said, before releasing the decryption key, it authenticates that particular server. Okay, there are a wide range of factors against which the server is validated. Of course, you as a customer, depending on the application which is running, you can yourself define the identity and integrity checks which the server should comply to before a decryption key should be released. And the decryption key, of course, when it is released over secure SSL channel. And lastly, it runs audits. It gives you alerts when the key request is generated, when the key is delivered. It also gives you wonderful reports on how many times the application requested access to data, what are the usernames which requested access to data, etc., etc. Right? So that's what Secure Cloud does for you. Let's get into a little more detail on how this exactly works. So on your left-hand side, you can see is your Secure Cloud Key Manager. Like I said, Secure Cloud Key Manager can either be hosted by Trend Micro, so you can have a beautiful SaaS console which we can give to the end customers. We'll give a username and password. You can access the key management server. Or if you're really very particular about managing your keys yourself, what you can do is we can give you an option where you as a customer yourself can host key management server, right? Secure Cloud Key Manager. There is another option wherein another service provider can also host it for you. So this is Secure Cloud Key Manager basically, wherein you create different identity and integrity check policies, and also this is the server wherein your encryption, decryption keys, all keys reside. On your right hand side, what you're seeing is a public cloud, okay, and it's a hypervisor. There are a couple of there are VMs there, and the VM, which is the pink colored VM, probably is your VM. And it is actually requesting access to your data, which is there in the shared storage, and a volume which has been assigned to you, right? So what we do is we encrypt your drive, the volume which has been assigned to you, install a secure cloud agent on that particular virtual machine which is hosting your application. Now, when this virtual machine wants to access the data which is there in the shared storage, which is encrypted, it sends a random session key over SSL to my key manager server saying that, okay, now I want to access my data which is encrypted. So what happens is that the Secure Cloud Key Manager does not just give the decryption key to the VM like that. What it does is it sends certain policy information question to the VM, which means now all these policy information questions are nothing but identity and integrity checks of this particular VM, which is your VM. And these policy information questions have been set by you, right? This VM sends certain policy information back to this key manager server. Now, there's an internal process wherein the questions, the questions of policy information which are requested and the answer which the VM returned, it's gone through an internal check. And only when all these questions are validated, only then the decryption key is sent to the server, and hence the server is able to access the data, right? So what we are doing, we are not actually providing you a certified encryption agent and industry standard encryption. We are adding a layer above it. We are making sure it's a policy-based encryption. So when I say about, I discussed about these internal processes and the policy information. What are these essentially? When I talk about unique server validation, what is this? This is identity check. So, so you can set policy that my server, when it is requesting the decryption key, okay, I want it to do an identity check. So you can set the question that what is the host name of this particular server which is requesting decryption key access? What are the embedded keys? What is the location? Which zone is it lying in? What are the last startup time of this particular VM, etc., etc. I mean, you can customize these policy, which will give you a peace of mind that yes, it's my VM only which is requesting access to my decryption key. So that will do an identity check for you. Then the second thing which the policy information contains are integrity check. Okay, now you know it's your VM, but is your VM compliant? Is your VM okay? Is it healthy so that you can release the decryption key? So what would be the integrity checks? Can be things like a simple thing like is the firewall on? Is the antivirus working? If you have an application and you have restricted only certain ports, you have opened only certain ports, you would want that, you know, if there are ports other than these ports which are open, do not release the decryption key. So this is what the identity and the integrity checks are all about. Now, only when these two criteria are met, the decryption key is released, like I explained. You can also add one more layer of security to it, that you can actually authorize, you can actually set that I should manually release the decryption key, you as a customer, or you can automate it. If these two criteria are met, identity and integrity checks are met, the decryption key should be released automatically, or you can even set it to a manual process. Okay. Now, what happens when this integrity check fails? Okay. Again, there is an option. If this integrity check fails, you have multiple options that you can do. You can do nothing, just log it so that you have that for your reference purpose. Or you can even do a stricter action, which is that you can revoke the encryption key, which means that that particular VM, because it has not met the server validation, even if it's your VM, or maybe due to some reasons, maybe it has not met identity checks. That means, is this someone else's VM which is requesting access to your data? So revoke the encryption key, right? Which means that VM will not get access to your volume which has been assigned, which is encrypted, right? So again, these identity and integrity checks can be scheduled. Okay, again, schedule can be defined by the customer, or you can define that these integrity checks should be run every hour or once a day, or whatever you want to do it. So this unique server validation can actually help you put one more layer of sophistication over and above the already FIPS compliant encryption agent which we are providing, right? So let's summarize in brief what Trend Micro Secure Cloud, what are the benefits. It provides you security. You can apply industry standard encryption. You can employ full volume protection, get real-time encryption, and make sure that your workloads are secured in the cloud. You have a choice. You can even encrypt your virtual environments. So for example, if you have a virtualized environment in your own data centers, you can even use Secure Cloud to secure your virtualized environment and, of course, the cloud infrastructure. This can be deployed as a software application, which means that you can deploy it in your own data centers, or Trend Micro can host it for you, and we can give you access to SaaS console. You get control. You can determine when and where your data is accessed by this unique policy-based encryption. You can ensure that only authorized VMs are accessing your data. And of course, all these factors add up to the compliance. This supports internal governance and compliance. You can address audits with reports and alerts on how you're handling data security in the cloud. And since you have all the trails of when the data was accessed, which VM accessed it, etc., etc. Right? So that was about Secure Cloud. Trend Micro has another concept when we talk about securing your workloads in cloud. One is that you encrypt your data in the cloud. And second is that we want that you should make your hosts self-defending, which means that when we talk about moving to the cloud, it's the journey, right? The data centers are evolving. So you might have at any point of time mix of physical, virtual, and cloud environments in your data centers, private clouds, public cloud, or hybrid cloud. So at any point of time, the virtual machine, if it is in a virtualized environment in your own data centers, it should have the security so that A host file, right? Typically, a host file is not modified very often, but you may want the host file to be monitored in case there is any change happening in the host file. That is typically what malwares do in order to redirect the traffic to some other site. In any case, if that is happening, you should at least get an alert. So that is what integrity monitoring is all about, right? You can actually monitor the integrity of important files, systems and processes and registry entries, of course, so that it gives you an alert of in case there is anything that has changed in the system. Okay. One important module that it provides is deep packet inspection. Now, when I talk about deep packet inspection, it is actually three modules divided inside this deep packet inspection. One is our host-based IDS IPS, which provides you functionality for virtual patching. Now, virtual patching has become very important in current times. You're seeing a lot of zero-day attacks, not even zero-day attacks. There can be even 3-month-old attacks, etc., etc. But the patching cycle is very cumbersome. There are certain databases which you can't afford to patch because it requires a restart and you can't provide the downtime. So virtual patching comes very handy in these situations. It also comes in handy wherein you have legacy systems in your legacy applications, say for example Windows 2000, etc. Right, for which the vendor has stopped releasing the patches, but your application still runs smoothly on it, and you don't want to change it. So you might want to use the virtual patching. So basically, what virtual patching does is it has a specific set of rules against each vulnerability which is released, OS vulnerability or application vulnerability, and it makes sure that if those rules are applied onto your virtual machine or onto your workloads, even though you're not patched, you will not be exploited. So technically speaking, even if you don't apply the vendor given patch, you're safe, but then that's not what we encourage customers to do. But yes, it will actually give you peace of mind till the time your patches are tested and deployed across your enterprise if you are virtually patched, because it's just a click away. This virtual patching has a very beautiful feature called recommendation scan. That is what most of the administrators struggle to do. Okay, I have host-based IDS, IPS in place. Now, how do I know which rules to apply on which machine, right? They are running different OSs, they are running different applications, right? So that is where recommendation scan comes into the picture. You run a recommendation scan on a bunch of virtual machines or a bunch of physical servers. It scans the OS, the apps, and then says, okay, these are the list of vulnerabilities, and these are the set of rules, virtual patches which I recommend for your app or for this particular operating system, right? This recommendation scan rule also ensures that there are no junk rules that are available on your workload at any point of time. Tomorrow, if you patch the system, you again run a again run a recommendation scan, and it will show you, hey, now you have patched your system, you don't need these virtual patches, remove these virtual patches, right? So at any given point of time, you'll be assured that whatever is available or whatever is present on your particular workload, whether physical or virtual or cloud, is what is required. It does not have any junk rules in place, right? So that is what virtual patching feature does for you. Web application protection, again, these are certain set of rules which help you to protect against threats like SQL injection, cross-site scripting. And let me also tell you that these rules are very customizable. Okay, we understand that when I talk about SQL injection, different SQL administrators have different sensitivity towards SQL injection attacks. So you can actually change these rules. You can define and change the threshold which should be met so that this rule can start acting, which will make this rule more sensitive or less sensitive depending on the nature of the application which is installed, right? So all these file protection modules are available, and these file protection modules can be installed on a physical server. It can be installed on a virtual machine. It can be installed on a cloud environment, and of course on a desktop or a laptop. But the idea being is that you have the same security which is available throughout the time your data centers are evolving, right? In certain instances, this security model can also be provided in an agentless manner. So there are certain hypervisors like VMware which have opened up certain APIs with security vendors so that our solution can work on top of it. So for a VMware hypervisor, these all protection modules are available in an agentless manner. So when I say agentless, which means that for all these protection modules, including antivirus, there is no need to install agent on each and every virtual machine on an ESX host. I just need to install one security virtual machine, which is another VM, which is integrated at the hypervisor level, and it takes care of all these protection modules for all the VMs. Right? So that was deep security. Again, reiterating what we discussed, to total cloud security, you need to have cloud security in the modular protection. You need to make sure that to combat against the present threats, which are APTs, data leak, etc. You need to make sure that your hosts are self-defending. You can have the security in the form of agent-based or agentless, depending on the hypervisor environment that you're using. And all these security modules should be accessed by one management console, be your VM in the virtualized environment or in a private cloud, or in a public cloud. There should be one management console through which you can access all your workloads. Again, this should be coupled with encryption with policy-based key management, which will give you access to when and where your data is being accessed, which will render data unreadable to unauthorized users. You should have the custody of the key. And these two solutions can work together. So for example, one of the integrity check in my secure cloud can be, is my deep security agentless, is my deep security antivirus running? Another check can be, is my deep security virtual patching enabled on that particular VM? Then only release the decryption key, right? So these two products or these two technologies can work together to provide you total cloud protection, and help you in your journey to the cloud, be it your physical server or your virtual machines or your private cloud, public cloud, hybrid cloud. This security stack can actually scale up as your data centers evolve and as and when you move towards your journey to the cloud. So yeah, and different cloud platforms which we support. Yeah, so that's about it.